Hello friends, welcome to the video lecture series on engineering and computer science related concept. So in this tutorial we are going to see about what is the Fourier transform. That is the one of the very important application in all areas of the engineering. So let's try to see what Fourier transform is. So for the Fourier transform we are not going to learn about any kind of mathematical formula in this tutorial. You will get hell lot of videos inside the YouTube or any other material related to mathematical formula of Fourier transform. You can see there and how you can calculate the transform, how you can calculate the magnitude and a phase of the Fourier transform. So in this tutorial we are going to see about what is the intuition behind the Fourier transform. Let's try to compare the analogy with our real life application. So let's just compare the one very simple recipe. This is the one of the salad recipe, and let's say we know about the we don't know about the what are the ingredients of this celery. This example we have taken to illustrate what actually Fourier transform is. Then we will compare this recipe example with actual our signal and we will apply the same formula for it. So suppose someone asks you that what are the ingredients of this recipe. This is one kind of salad. So how you can come to know about what are the ingredients of this celery recipe? If you know about the ingredients of this recipe, you can even recover back to its normal recipe. So let's say we'll apply some kind of cucumber filter or a tomato filter, olives filter. This is all about our intuition, but it should try to capture all those information from this salad, like a cheese filter, apple filter. So this recipe is just for illustrated purpose. I have already written. The actual content of this recipe ingredient may vary. So suppose if you apply the cucumber filter, so we'll get output something like it may have 100 gram cucumber we have already applied. So whatever the output of cucumber filter. Suppose we apply the tomato filter, we may get like 2 tomatoes we have already inputted. So in this way we are all getting the different ingredient through which this recipe has been made. We have applied the chicken filter. Oh sorry, there is no chicken was available as it is a vegetable salad. There is no chicken available, so chicken filter is 0. If you apply cheese filter, there is a 50-gram cheese are available. If we apply the apple filter, there is a 1 apple also we have put in. So in short, for this recipe we have got this many ingredients. Forget about this chicken part now actually. So now we have all the ingredients required to make this recipe again. So if we mix it in a proper manner, we can again recover back this whole recipe. Now let's try to correlate this example with actual our Fourier transform. So by this example we came to know about that every single component as a part of signal or any other object in this universe is made of another tiny subset of different ingredients or different another component. The same way signal is also made up of different component. So Fourier transform which directly try to capture this way the frequency of the data. The same way we are capturing the cucumber data, the tomatoes data, olives data, the chicken data, cheese data or apple data. Same way we apply the Fourier transform on the top of this signal. Signal is nothing but our input. Input is nothing but the recipe, the full recipe made up of full ingredients. And all those filter will give us what are the frequencies are available inside this original signal. So let's try to correlate with the Fourier transform. Let's say we have a signal, and the way we applied the different filter earlier, we applied the same filter like a low frequency filter, then a mid frequency filter, then a high frequency filter. Same way we'll get the component of low frequency signal output, mid frequency signal output and high frequency signal output. That is what the Fourier transform is. So in short, Fourier transform is trying us to know that what are the frequency components are available inside our input signal. So let's try to see it with the actual example. let's say we have a very simple digital signal like a 1 1 1 1 1. So all values are same, there is nothing change, so it contains only low frequency signal. So when we apply the Fourier transform on the top of it, the low frequency components has a very high value, and a mid frequency and high frequency component has a very low value. Let's try to see with little change in a input signal. Let's see, we have a signal like a 101010, so it's continuously changing, so it must have a high frequency signal component associated with it. So when we apply the Fourier transform on the top of this signal, these components will get bigger. So in summarize, we can say that Fourier transform help us to trying to know about the what are the ingredients available inside the original signal, and ingredients are nothing what are the different frequency component. So input signal is we will try to correlate this with our recipe example. So input signal is nothing but our recipe. We apply the low frequency filter, high frequency filter, mid frequency filter on the top of, which is nothing but the Fourier transform filter, which is equivalent to our banana filter or a apple filter, olive filter, chicken filter on the top of recipe. And whatever the output we got out of this, that will tell us whether that particular ingredients or particular low frequency, mid frequency or high frequency component exists in our input signal. Suppose we apply this mid frequency or low frequency filter on the top of, we'll get a no. Same way we have got no in case of when we apply the chicken filter on the top of that vegetable salad. So this is the most intuitive way to understanding the Fourier transform, that every signal is made up of different component which is of a different frequency. Now let's try to see some of the application of Fourier transform. What advantage we'll get by breaking the signal into different component. So we have broken the recipe into its ingredients of the recipe. So how it will be helpful? So it may happen that you can remember in your old days or when you were in a childhood, for some of the recipe, some part of ingredients or some ingredients you like a most, or some ingredients you don't like a most. So while eating, you always try to put the filter that for the particular ingredients, and whatever the ingredients you like most, you eat it first, and whatever the ingredients you don't like, you just leave it as it is. You may remember this kind of phenomena happen with your childhood. So it will help us to extract the your likable ingredients or your unlikable ingredients. When you are trying to apply those filtering for your likable ingredients and unlikable ingredients, implicitly you are trying to extract some component out of that full recipe which you can consider equivalent to the Fourier transform. Let's try to see another application. This is not actually application, I am just trying to analog with our actual example. Earthquake vibration. So earthquake vibration contains many different frequency signal component. So if we suppose the dig down this earthquake vibration signal into different frequency component, then while designing the buildings, we can design in a such a way that whatever the highest strength signals are available based. So how we can design this building better to tolerate that particular highest frequency signal, highest magnitude signal. If we have a different component of that available, then we can take those decisions. So this way Fourier transform is very helpful while designing those buildings. Image in a video signal, so that will be helpful for the compression purpose. Suppose we have an image and video signal which is a very huge in size in a uncompressed format. So once we apply the Fourier transform or any kind of this kind of transform on the top of it, we'll come to know about that there are some of the components are available for very high in particular frequency range, and there are some of the components which is high in a high frequency range. So it may happen that we can boost some signal which is very visible or audible to us and which is not useful. We can just discard those signal, but same way time we are preserving the actual information. It will be a lossy compression but still looks like exactly the similar signal. It won't be the exact, but partially exit the signal. So that's how the compression will be helpful. Radio waves. Now every time we open the radio, we have to tune the channel. Why we need to tune the channel? Because once we open our receiver, every time the receiver receive a hell lot of all the signal directly to our antenna, but we want to hear some particular channel only. But any time all the radio signal of all frequencies are keep coming, but we need to hear the particular frequency channel only. So if we apply the Fourier transform on the top of whatever the input signals are coming, you can extract particular frequency range component only, and you can suppress all other frequency component. That's how the Fourier transform is useful for extracting the radio wave signal. So that's it for this lecture, friends. I hope you enjoy listening this video. Please do like, comment and subscribe it.